Hello, this is Bryant Myers, and welcome to another episode of Debunking Flat Earth. In this episode, we're going to go over one of the objections I've been hearing lately from flat earthers, that the images coming in from Artemis Orion are not good enough. They're too low resolution, etc., etc. So we're going to go through how these images are taken and why they are the way they are. So NASA has released the first images of the moon taken on the Artemis mission, and in my opinion, they're spectacular. Early on Monday morning, the Orion spacecraft did a flyby of the moon, passing roughly 80 miles above the lunar surface. The images were taken by the Orion thanks to cameras installed on the vehicle's solar wings. There were not any astronauts on board the crew capsule for this Artemis 1 mission, but the images show us what they will see when they fly by the moon on Artemis 2 in just a few years from now. The images were captured by GoPros, but not the kind you can buy off the shelf, as we'll see. When humans first traveled to the moon on Apollo 8 back in 1968 and landed just 7 months later with Apollo 11, the images they sent back were historic. Here you can see the Apollo 17 famous blue marble image, and to this date it's still my favorite image of the Earth from space. And it was taken by Harrison Schmitt with a handheld Hasselblad 70mm camera with an 80mm lens. And now flat earthers really hate this photo for a couple reasons. It was actually taken with a real camera developed in a darkroom, not digital, not a painting, not CGI, not fake. It's not anything but a real full disk image of our spherical Earth. Another reason flat earthers hate the image is it was taken showing Antarctica from space, and that's one of the reasons why they actually took the shot. It's like, look, Antarctica's out there, let's take a shot of the Earth. So this one photo alone, in my opinion, is a nail in the coffin of the flat Earth. And I did a whole video on this, and I'll put a link below with a few other references so you can see it's absolutely an authentic image. Not only that, on the other missions, there was all kinds of high-resolution images taken from this real camera, developed in a darkroom, real images, and probably my second favorite is the famous Earthrise image. And this too, and I went through photo forensics on both of these images, and I could find nothing going on that was suspecting of anything other than real images. And when you compare the time and date and the cloud cover, the size, I mean, it's just a match that it really happened. But again, check out my other video for this. And 50 years later, we are no stranger to images from space. So again, as much as flat earthers are complaining about the Artemis Orion images, we're getting hundreds of images every day from Himawari 8, GOES 16, 17, every hour from Discover, Meteosat, the European satellite, Electro-L, the Russian satellite, and the China FY4A, which they may have a better upgrade on that now, but the point is we're getting these full disk images every day, and I've done a separate video on the Himawari and GOES, and I've yet to hear any rebuttal to it. Globebusters did a whole show on my first Himawari video, and then I just annihilated it and answered all their objections, and I've heard nothing but crickets from them. They have no answer because these are real images from space, and you can match cloud cover with you can literally go outside, see cloud formations, go on the GOES satellite or Himawari if you're in the Eastern Hemisphere, and you can see the cloud cover matches what they're taking. So anyway, check out my other video on that because these images are absolutely real. And then the space station orbits the Earth 16 times every 24 hours, which enables astronauts to capture incredible high-resolution footage of the planet's impressive landscapes, bright blue oceans, and sweeping auroras, as well as the magnificent nighttime glow of our city lights. So again, this is, to me, the ISS is another nail in the coffin of flat Earth because you can actually do like Reds Rhetoric and Astronomy Live did, is you can confirm the altitude of the ISS using simple triangulation. It's not hard, actually. It just takes a little bit of planning for a lunar transit. And you can even calculate the velocity, and you'll see that it is way too high to be just a balloon or a plane, 400 kilometers or 250 miles, roughly. And it's going 17,400 miles an hour. And again, you can calculate these numbers. Where's Wally and a couple of his friends did some simple velocity calculations just by picking a celestial line in the sky, and they all looked at exactly when the ISS crossed that line, And it's not hard to calculate the velocity of the ISS from 2 or 3 measurements like that. Again, this absolutely debunks the flat Earth, because they say that space is not possible, the ISS is not possible, and that, orbital mechanics can't work. And they're always saying, well, show us, orbital mechanics here on Earth. Well, there you go, flat earthers. The ISS is doing this every day, 16 times it's going around the Earth every day and giving us, but pretty much, around the clock, whenever the ISS is in range, you're getting live footage, and you can go on YouTube and see the live feeds from ISS. And we've gotten many other images from the moon and even from Mars. This image here you can see is a striking image taken from the Mars Reconnaissance Orbiter in 2007. So I just wanted to go through that, and there's many, many more examples of many images taken from satellites orbiting the Earth, satellites orbiting the moon, that we have of the Earth, not just with NASA, but with other space agencies as well. And it's now just in at least the hundreds of thousands of full Earth images. And what do flat earthers have? Little toy models and cartoons of some disk in space.
This is easier to understand than this. And you say, well, that doesn't mean it's right. It's like, isn't it? Why not? We believe all sorts of things, but the public tends to lean towards the easiest explanation. It's why we text instead of no.
Gross round Earth. Gross round Earth. Pretty flat Earth.
Just absolutely ridiculous depictions. And they complain about our images from space, or say that these images are CGI. It's just laughable. I mean, again, I keep demanding flat Earth. It's like, okay, what do you guys got? And the best they got are these high altitude balloon shots that are cherry picked when the frame of the camera of a fisheye lens is above the center of the frame, so that way it flattens out the curve. And I even caught Dearth in one of his videos where it ended up being upside down curvature, the concave curvature. Okay, so getting back to Artemis Orion. So the first images from Artemis are still, in my mind, mind-blowing. This is the first time NASA has sent a human-rated spacecraft into deep space in 50 years, and it is going further than any other crew-rated vehicle has ever gone before. When it finally lifted off in the early hours of November 16th, the Artemis launch thankfully went off without a hitch, and we got an amazing view of the space launch system at Cape Canaveral, sending Artemis 1 Orion into space. And Astronomy Live and Red's Rhetoric had a wonderful footage of this liftoff. Check out their YouTube channels. And Astronomy Live was actually able to capture the Artemis Orion coming back around right before its translunar injection burn, right where NASA said it would be. At the time NASA said it would be there. Just amazing confirmation that this is a real launch and that it happened and that it's on its way to the moon, and the images we're getting are real, and everything about this mission is real. So anyway, getting back to the takeoff, after the rocket boosters were jettisoned and Orion unfurled its solar wings, we got our beautiful first images of the Earth, as you can see here. And then as it went further out at 57,000 miles, you can see this image here. And I just love this. And I did a whole video on this, taking it through photo forensics, comparing it with the weather patterns from the GOES 16 satellite, and they all matched. And I went through a few other steps too to show that these are real images. Just beautiful. Now this image here was taken from the navigation camera, so it's a lower resolution, but I was able to, and I did a little YouTube short on this, confirm the weather patterns with the Meteosat European weather satellite. And here you can see kind of my confirmation, and I'll put a link below if you want to go through these. You can match the weather cloud cover and see that the weather satellites do match the actual feeds. Now, I just want to play this little footage that came in yesterday, and when I watched it, it just really moved me. And it's about a minute, but please just watch this and take it in.
And here you are looking at a live view of the Orion spacecraft from the solar array wing, with the moon in the distance of the screen, the Earth in the distant frame of the screen, and the moon up close. Again, we are now less than 2,000 miles away from the moon, but over 200,000 miles away from planet Earth. Now less than 4 minutes away from our expected loss of signal as Orion travels behind the moon. This outbound powered flyby will send Orion close enough to the lunar surface to leverage the moon's gravitational force and swing the spacecraft once around the moon toward entry into distant retrograde orbit. This is actually 30,000 miles farther than the previous record set during Apollo 13 and will be the farthest in space any spacecraft built for humans will have ever flown.
Isn't that just beautiful? I mean, it's just, for flat earthers to say this is fake, it's just a slap in the face on human innovation and progress and just the world we live in now and all the technological advances we have. So I just want to go through, because again, like I said, the flat earthers are objecting to the quality of these images, even though I think they're beautiful. But let's look at the hardware behind all these images and the guy behind it all, David Melendrez, and let's just hear him introduce himself here.
Well, my name is David Melendrez, and I'm the imagery integration lead with the Orion program at NASA Johnson Space Center.
Okay, so he's the one that's kind of in charge of all these images, and again, his job is to oversee the operations of the cameras. There are 13 cameras installed on the Orion, inside, outside, and on the spacecraft's solar arrays. They are a mix of industrialized cameras from a Canadian company called Pixelink, which you can see here, plus some very highly modified GoPro's cameras. So NASA opted for the GoPro Hero Black for this mission, but with a lot of adjustments. Let's hear Melendrez explain.
Some of them are highly modified GoPros. I would not say you can go out and get them because you can't. They've been taken apart, reprogrammed, there's a new lens. They've been basically completely rebuilt in order to survive a deep space and rocket flight environment. You have to take care of the circuit boards and make sure things aren't going to fall off because they do have to go through vibration testing. We've had to attach heaters to keep them warm in deep space and just generally do our best to make sure they're not going to keel over when you're on the far side of the moon.
Okay, so you can see that these cameras, there's a lot that went into building these cameras to make them space ready. And again, they were completely rebuilt in the case of the GoPro, and because they got to survive the really cold temperatures and the vibrations of deep space, etc. So when you're going out past the moon, how do we get these images back to Earth? Well, the answer is radio. For this, NASA is using its Deep Space Network, the same network it is using to communicate with the James Webb Space Telescope. The Deep Space Network is a network of telescopes in Madrid, Gulfstone, California, and Canberra, Australia. And you can see from this image here is that these locations are not just randomly picked. They're picked in such a way that NASA is always getting a full 360-degree view no matter where the satellites are at when they go beyond 30,000 kilometers. And so basically, if you look at from the South Pole, these cameras are located like 120 degrees apart, so that gives them a 360-degree view. This is a two-dimensional Earth, so it's harder to see here. And here you can see some of the satellites besides the deep space. There's also near space network, but the red ones here are the 3 deep space telescopes. And this is how these images are coming back. But even with the deep space network, getting these images back to Earth is quite a feat. It's not like the ISS, which is in low orbit. It's much more of a challenge. Let's let Melendrez further explain.
So to go all the way to the moon, it's not like Station. Station, we're used to getting megatons of video. That's in low Earth orbit, that's right across the street. From the moon, to get a live stream video at what folks would expect as 4K video quality. Well, I can get 4K video on my iPhone, but you're not doing it from the moon.
Yeah, and that's the key. You're not doing it from the moon. Another thing that's really important to bring up is the images are sharing bandwidth with other really important communications and telemetry data that is coming down from Artemis. So there is a lot to squeeze through this downlink. Due to the restricted bandwidth, mission-critical data is prioritized, and some high-quality views may not be available until long after they're captured, meaning when they come back to Earth. Further, each camera has been optimized to capture imagery of the spacecraft rather than deep space. NASA points out the imagery for the Artemis 1 flight will depend on a variety of factors such as lighting, spacecraft orientation, and communication abilities and capabilities during different mission phases. This is why a lot of the live feed video has been reasonably low resolution, even though, again, I think it's beautiful images. But there is an upside to all this. NASA is going to be recording several hundred gigs worth of data, and about 2/3 of it will stay on board the Orion spacecraft. When it comes back to the Kennedy Space Center, we are going to have a huge amount of amazing footage to see. Beautiful high-resolution footage of the Earth, Moon, and everything in between. So just be patient, flat earthers. Be patient, everyone. Even much better images are coming. But still, what we've been given so far is amazing confirmation that we live on a beautiful, spherical, rotating Earth that is orbiting our sun, and within our solar system that is orbiting our galaxy, which is going through deep space around our local cluster. And it's a wonderful and magnificent mystery. But science has shown us amazing confirmation that the model that we have as our current scientific model is incredibly accurate in predicting the world, the solar system, the galaxy, and the universe we live in. So thanks for watching. I hope you enjoyed this video. I hope this answers some of the objections to those flat earthers watching or some on the fence, because I'm excited for these high resolution images to come when Artemis comes back to Earth. So thanks again, and do like this video, subscribe to my channel. I have many more coming, and I hope you have a great rest of your day.